Hello everyone, my name is Yusuf and I'm part of the team Schism. Over the past month, we've been working together over a project, which is a car. We used the Arduino Mega and FreeRTOS to create this car. The reason as to why we made these decisions is because the Arduino Mega has way more pins than the Arduino Uno, and because we will implement a lot of things on this car, we figured that we need a lot more inputs into the Arduino board. The second reason that we used, is for the FreeRTOS is that we needed a way to schedule between the tasks that we've implemented. For the modules that we've made 3 modules. The first module is the automatic emergency braking system, which uses sensors to stop the car. The second module is the heads-up display, which uses an LCD to display general information about the car. And the third module is the keyless entry, which uses an RFID writer and a push start button to start the car.
Hello everybody, I'm Andrew, and I'm going to talk about the RFID, which we use to indicate that the car is locked or unlocked. Here, if we can see on the LCD, it's now locked. If we passed the key on the RFID, now it's unlocked. We used on the RFID the UID of this card and this key, which in this case the car can't be opened unless we use this key or this card. The next step is the button. If we pressed on the button on the LCD, the car now is on, which we'll see with Ahmed Kalani after a few seconds. If we pressed on the button again, the car is now off. Now we can unlock the car with the RFID. We used semaphores to indicate the sequence between the RFID and the button, where we used a mutex between the RFID and the button. If the car is locked, the button can't be pressed, as we can see in this case. But between the button and the rest of the components, we used a binary semaphore, which we'll talk about in a few seconds. Thank you.
Hello, I'm Ahmed. And as Andrew mentioned a few seconds before, that we use binary semaphore. The binary semaphore is used when the button is pressed and when the car is turned on. Every feature in the car uses the binary semaphore in order to operate. And now I'll talk about the LCD module. As you can see, we use the LCD module to display the current time, which is obtained by a clock module, external clock module, and it also shows the current gear of the car, which we set using this joystick. And also you can see that the temperature is displayed on the LCD using a temperature sensor that displays the current temperature outside of the car. And now, talking about how the car operates, we will have Bassem Ayman.
Hello everybody, my name is Bassem Ayman. I'm going to talk about the module of the movement of the car. We used an AEB L298N to control the 4 DC motors of the car. We connected the right side wheels to the right side output of the AEB and the left side wheels, the front and back wheels, to the left side output. We also used the PWM output from the Arduino to control the velocity of the rotation of the wheels of the car. And we used also a 9-volt battery, which we connected to the AEB to control the 4 DC motors.
Hello everyone. We've talked a lot about the modules that we've used in the car, but we haven't talked a lot about the sensors, and that's what we're going to do right now. First of all, let's talk about the joystick sensor that we've used. And that analog sensor determines which gear you're on. So let's say, like right now we're parked, okay? You pull it up for drive, down for reverse, and back for neutral. And what that does is it returns back a value to the Arduino, and based on a range of that value, we determine which gear we're on, and based on that gear, the behavior of the car changes. So let's park the car, and it's parked, it's displayed on the LCD. Connect the car, and let's put it on drive. On drive, it will start running. reverse, we'll go back, and we park it to stop. But let's go back to the drive mode. What if we're driving and there's an obstacle ahead? What would happen? Now it's parked, it won't buzz. But if it's not, it will start buzzing, and then once it's close enough, it will stop. Now let's park it again, remove, and there will be no buzzing whatsoever. How that's implemented, we basically use the ultrasonic sensor to push a sound wave, and it receives the echo back. Once the echo is received, based on the duration it takes to receive back the echo, the distance is determined, and once we've reached a certain distance, the car starts buzzing, and once we've exceeded that distance, the car stops buzzing and it starts stopping. We've also used the photo sensor. What that does is it turns the LEDs on if we're in dark mode. Okay, so let's just turn off the lights for a second. And the LEDs turn on. We turn back the lights, and they're off. And that's all. Thank you.